Ever imagine yourself, I don't know, sipping hot cocoa on a cruise ship and like dodging icebergs?
Right.
Okay, maybe not your typical vacation,
Yeah.
but trips to the Arctic and Antarctic are really booming.
Yeah, they are.
And that means more ships navigating some seriously treacherous
It's
waters.
fascinating, isn't it? This surge in activity from commercial shipping to tourism and even military operations, it's really putting a spotlight on a very old challenge,
Mhm.
how to navigate safely through ice-choked seas.
And that's where our deep dive begins today. We're diving into a research paper about how AI is being used to help ships navigate these increasingly busy polar regions.
And this isn't just some futuristic fantasy. The Spanish Navy, for instance, is deeply invested in a project called AMADS,
Okay.
using AI to analyze satellite data and make polar navigation safer.
Okay, color me intrigued. Where do we even start with something like that? What's the AI actually doing?
Well, think of it this way. Imagine trying to navigate a maze, but the walls are constantly shifting. That's what it's like for ships in icy waters.
Hmm.
The paper outlines two main ways AI is being used to tackle this challenge.
Okay.
The first one we'll explore is called drift ice detection.
Drift ice detection.
Yeah,
Sounds pretty self-explanatory. Is it basically teaching AI to spot icebergs from space?
exactly. We're
Like,
talking massive chunks of ice that could spell disaster for even the sturdiest ship.
right.
AI is trained on satellite images to identify these potential hazards.
Okay. Sounds like a no-brainer. What makes it so tricky then?
Picture this.
Hmm.
A pristine white iceberg, easy to spot against the dark water. And now imagine that same iceberg starting to melt.
Right.
The edges become blurred, the surface changes. It's much harder to distinguish from the water, even from space.
Ah, I see. It's not just about seeing white shapes. It's about recognizing the ice in all its different forms.
Mhm.
So how does the AI learn to do that?
One technique they're using is called IRGS,
Okay.
short for Iterative Region Growing with Semantics. Imagine giving the AI a special magnifying glass. It doesn't just see individual pixels in the image.
Right.
It analyzes groups of pixels looking for patterns, shapes,
Yeah.
even subtle variations in color that indicate the presence of ice.
So it's like giving the AI a deeper understanding of what it's looking at, even when the ice is trying to camouflage itself in the water.
Exactly.
That's wild. But I'm guessing spotting individual icebergs is only part of the equation, right?
You're exactly right. It's like navigating a city, you know.
Oh, okay.
Knowing where the potholes are is helpful, but you also need to understand the overall traffic flow. That's where the second approach comes in, sea ice concentration estimation, or SIC.
Okay, so less about dodging individual icebergs and more about understanding the bigger icy picture.
Precisely. Imagine a heat map for ice density.
Right.
Red zones mean you're in for a slow, potentially risky journey. Blue zones are relatively clear sailing. SIC helps ships find the most efficient routes through these icy landscapes.
So it's like having a real-time ice roadmap. I bet that's invaluable for planning ahead, especially for commercial shipping routes.
Absolutely. And here's where it gets even more interesting. Researchers are working on predicting not just the ice concentration, but also the uncertainty in those predictions.
Wait, predicting uncertainty? That sounds kind of meta. What's the benefit of that?
Well, AI models aren't infallible.
Right.
Sometimes the data is fuzzy, literally, when you're talking about satellite images of melting ice. By quantifying uncertainty, the AI is essentially saying, I'm 80% sure this area has low ice concentration, versus I'm only 50% sure about this region, proceed with caution.
Wow, so it's like AI is giving a confidence level alongside its predictions.
Yeah,
That adds a whole new layer of decision making for the captain.
exactly. That nuanced information can make all the difference in navigating safely and efficiently. This focus on uncertainty highlights a key difference between how these two approaches are used in navigation.
I see what you mean. Drift ice detection is about avoiding immediate danger, while SI is more about strategic planning and risk assessment on a larger scale. So, if you were captaining a ship through these waters, which approach would you find more valuable?
That's a tough one.
Yeah.
They both play crucial roles. Drift ice detection is like having a vigilant lookout on the crow's nest, while SIC provides the overall nautical chart for the journey.
It's like you need both the zoomed-in view and the wide-angle lens to navigate effectively. And I'm guessing the technology behind both approaches has some overlap.
You're right on the mark. Both often utilize convolutional neural networks, or CNNs.
CNNs.
Yeah.
Those are those powerful AI systems that excel at image recognition, right? I've heard they're used in everything from self-driving cars to diagnosing diseases. What makes them so suitable for this?
They're like these super sleuths of the AI world when it comes to images. They're designed to learn hierarchical features. In simpler terms, they can recognize patterns within patterns, from simple edges and textures to complex shapes like, well, icebergs. But here's the key. Even though they might use the same type of neural network, the training data and the goals of the models are completely different for drift ice detection and SIC estimation.
So it's like training a dog to sniff out different scents, even though they both have the same incredible nose.
Right.
One's trained to find that missing sock, while the other's trained to detect specific types of ice in satellite images. That makes a lot of sense. Okay, let's bring it back to that Spanish Navy project we mentioned earlier, MADs. They're using AI for safer navigation, right? Which approach are they focusing on?
So the Spanish Navy with their MADS project, are they more focused on spotting every chunk of ice or getting a sense of the overall ice density?
Their paper highlights their focus on sea ice concentration estimation for the MADs project.
Okay.
Specifically, they're utilizing a type of CNN called UNet.
Okay.
It's been a bit of a star player in the world of image analysis.
Right. Known for its ability to make accurate predictions even with complex images. And that's critical when you're trying to create reliable sea ice concentration maps for navigation.
UNet, it sounds like they're pulling out all the high-tech stops for this. And they're pulling data from something called AI for Arctic, right? What can you tell us about that?
It's a fantastic testament to the power of collaboration in this field.
Okay.
AI for Arctic is all about pooling resources and knowledge to build up a high-quality data set focused on the Arctic. This shared data treasure trove helps researchers develop even better AI models for a whole range of Arctic challenges, including, of course, this whole navigation puzzle we've been exploring.
It's incredible to think that we're using cutting-edge AI to solve a challenge as old as, well, ice itself. It's like we're witnessing the next chapter in the history of exploration and navigation.
It really is remarkable, and the potential implications go far beyond just safer shipping lanes.
Right.
As AI gets more adept at navigating these icy waters, it could open up new frontiers for scientific research, resource management, maybe even sustainable tourism in these once inaccessible areas.
It's like opening up a whole new world. But with that comes a big dose of responsibility, right?
Absolutely.
More traffic in these pristine environments, even if it's for research or sustainable purposes, could have unintended consequences.
Absolutely. It's a classic double-edged sword scenario. This incredible technology has the potential to deepen our understanding and appreciation of these polar regions, but it also underscores the importance of careful planning and responsible development to ensure we're not disrupting these delicate ecosystems.
It feels like the AI is giving us a sneak peek into the future of polar exploration, and now it's up to us to chart a course that balances this incredible potential with the need to protect these fragile environments.
Okay.
Definitely a lot to think about.
It is. But that's the beauty of these deep dives, isn't it?
Yeah.
They not only equip us with knowledge, but also encourage us to grapple with the bigger questions, the what-ifs and what-nows that inevitably arise alongside these technological advancements.
Well said. And on that note, we'll leave you with a final thought to ponder. As AI steadily removes the barriers of navigating icy waters, will we see an increase in human activity in these once isolated regions? And if so, how can we ensure that this increased presence benefits both humanity and the delicate balance of these polar ecosystems? Something to chew on as we continue to explore the potential and the responsibility of AI in our rapidly changing world. Thanks for joining us for this icy deep dive.